Jai Hind everyone, myself Sandeep Yadav, working as an assistant professor in CSC department. In the series of lecture on complex topic in DBMS, today I am going to deliver a lecture on relational algebra. Outline of the course are selection operation, projection operation, cross product, join, set operators, division, rename, aggregate functions. Now, what is relational algebra? Well, relational algebra is a procedural language. That is, you have to specify what data is required and how to obtain the data, right? It is a collection of operation to manipulate a relation, to derive a new set of relation. Now, following are the operations in relational algebra. Number one is select operator. It is denoted by the sigma and notation is sigma subscript condition followed by the name of the relation. It selects the tuple from a relation that satisfies a given condition. Operator can be anyone, greater than, less than, equal to, not equal to, and or not. Now, suppose we want to display the detail of the student belonging to the branch civil engineering. This is a relation, student relation is, this is student relation whereby roll number is there, student name is there, branch is there and SPI is there. SPI is student performance index. So, these are the branches mechanical, civil, CI and CE. Now, suppose we want to retrieve the tuples belonging to civil engineering department. Now, we have to specify a condition that the branch is civil. So, we are going to write as pi, then the selection condition, we have to tell what is the selection condition, that branch equal to civil and SPI is greater than 8 followed by the name of the relation student. This is how we perform the select operation. It actually select operation is performing the horizontal partitioning, that is it divide our table into two parts, one that meet the condition, one that does not meet the condition. So, whole of the purpose of select operation is the horizontal partitioning of the relation. Now, this will be the output 101 meet branch civil and SPI is greater than 8 which satisfies the condition. Now, another example, display the detail of the student belonging to CI or mechanical branch. So, how to specify the condition? Now, condition can be specified as selection operation denoted by sigma, branch equal to CI, or we are using the or operator and branch equal to mechanical followed by the name of the relation student. Now, this will be the output. What is branch is there? Mechanical branch is there and CI branch is there. So, output will be 101, 103 Nilesh CI 9 and 102 Mitesh ME SPI 9. Now, another example, we have to display the detail of the student whose SPI lies between 7 and 9. So, we have to display the detail of all the students whereby the SPI lies between 1 and 9. So, we have to write a query again. The query is select statement, then we have to specify the condition. Condition is what? SPI is greater than lies between 7 and 9. So, SPI is greater than 7 and SPI is less than 9 means it lies between 7 and 9. Now, this query will fetch the following answer. Only one of the rows or the tuples 101 corresponding to Raju and civil branch having the SPI 8. Rest all are having SPI 9. So, they cannot be included in result and nothing SPI is 7 or greater than less than 7. Now next operation is project operation. Suppose we want to retrieve our attributes. Suppose we want to find the name of the student in a class, then how to find the data vertically, that is column wise. We have to find the data column wise, that is we have to perform the vertical fragmentation. For that we will be using project operation. Now symbol pi will be used for project operation. Now how to notate it? Pi followed by the attribute set, attribute 1, attribute 2 up to n number of attribute can be mentioned in the subscript of pi, followed by the name of relation. Now this operation will select the specified attribute, means whatever attribute we mention in this pi, attribute 1, comma attribute 2 up to attribute n can be there depending on the requirement. It also remove the duplicate tuples or the records from the result. Now we have to find the roll number, name, branch of all the students, and the table is student table again. Roll number is there, name is there, branch is there, SPI is there. What we have to find out? We have to find out roll number, name and branch. So we will write pi roll number, comma name, comma branch, followed by the relation student. So that will be the answer, pi roll number, name, branch, followed by the name of relation student. Now suppose we want to find out the name of the student whose SPI is greater than 8. So that needs vertical fragmentation as well as the horizontal fragmentation. So we are going to make use of both vertical fragmentation as well as the horizontal fragmentation. We have to specify certain condition. To specify certain condition, we need a select operation, and to find particular attribute we have to make use of project operation. So most of the query use both project operation as well as the select operation. Now this is the query: display roll number, name and branch of mechanical branch student. So the condition is the student must belong to the branch mechanical. So that will be specified using select operation, and roll number is attribute, name is attribute and branch. These will be specified using projection. So we have to make use of both projection as well as the selection operation, and we will write the query as follows. Step number 1, we have to specify the branch. To specify the branch, we are making use of select operation, branch name equal to mechanical. Now next is, now you are getting the branch. Now in this we have to refine it. We have to refine it. Now pi roll number, comma name, pi roll number, name, branch, and what the condition? Branch name equal to mechanical followed by the name of relation student. So this query will ultimately provide the following answer: roll number, name and branch. Is specify the condition that branch name is mechanical. So output will be only this one. Only one tuple will be in the output. Now another query: display branch, name and SPI of student where SPI is greater than 8. Again we will write step number 1. First we will have to specify the condition that SPI is greater than 8. For that we are going to make use of select operation, that SPI is greater than 8 that we have mentioned. Next, this will be the output. Only 2 students are having SPI greater than this. So that will be our first step. Next step is we have to find the name, branch and SPI. So name, branch and SPI. In order to find out that, we have to use project operation again. So name will be this one, Mitesh, branch will be mechanical, SPI is 9, Nilesh, CI at 9. So in this way we are making use of both select as well as the project operation in order to find the desired results. because we have to perform both horizontal as well as the vertical partitioning. One more query, display name, branch and SPI of student belonging to civil branch and SPI is greater than 8. So, this has two conditions. First, the branch is civil and C branch, and second, SPI is greater than 7. So, first step we have to specify the condition. Condition is sigma branch equal to civil and SPI is greater than 7, followed by the name of relation. So, this will give you the following output. Only one of the output is there, that civil branch student is 1 and having SPI greater than 7. So, entry will be 101 Raju civil and SPI is 8. Now, we have to show only the attribute name, branch and SPI. So, we have to make use of project operation. Now, the answer will be pi name, branch, SPI followed by the select condition. Select condition is branch name equal to civil and SPI equal to 7 and followed by the name of the relation student. So, answer will be name, branch, SPI, where name is Raju, branch is civil and SPI is 8. Now, one more query, display name of student along with the branch who belong to mechanical or civil branch. So, we can write the query as pi name branch, where statement, that is select statement, branch equal to mechanical or, the symbol or, this symbol is or as we use in discrete mathematics, and branch equal to Ci and followed by the name of relation student. So, this will fetch you the both attribute name as well as the branch, and this will be the output Mitesh ME and Nilesh CI. Only these two tuples are meeting the requirement. Now, next operation is Cartesian product. Cartesian product is basically the Cartesian product is a type of cross join, we can say. It is denoted by the symbol cross. Notation is relation R1 cross relation R2 or algebra 1 cross algebra 2. It multiply each tuple of relation 1 to each tuple of relation 2. Now, the attribute of the relation resultant relation equal to the attribute of relation 1 plus attribute of relation 2. So, we can see in this case how much attribute will be there? Attribute of 1 plus attribute of 2, total 5 attributes will be there. Now, the tuple, how much tuple will be there? Now, in the resultant equation, the tuple will be tuples of R1 cross tuple of R2, that is 2 into 2, that is the value. The resultant equation will be having 4 tuples. This is how we are performing. First combination of 101 Raju is of civil is with 101 this one. Second combination is 101 Raju civil with this one. Third, make a combination of second row of student table with first row of result relation 101 SPI 8. Second combination with second row of the result. So, you will be having total 4 relation in the output. This is the output student dot roll number, name, branch, result roll number, result dot roll number and SPI. Here, see here we are mentioning the name of relation before roll number this one and before this roll number, so that there is no ambiguity at all. It indicates that this roll number belongs to the student table and this roll number belongs to the result one. So, this will give you the 4 tuples. So, Cartesian product as such is a useless operation unless until some condition is specified you. Otherwise, it will give you the total number of combination permutation possible. No one is interested in all those things. We need to carry out only Cartesian product followed by certain select operations. If both relation have something common attribute with same name, it can be distinguished by combining relation name dot attribute name as I have stated earlier. Now we have to perform the cross product between the student and the result. These are the two relation, student relation and result relation. So we are going to perform the cross product. So we will here we are considering only selected attribute of relation. Of student we are considering only roll number, name and branch, and result we are considering roll number, SPI and BL. That is, BL stand for backlog, that a current back a student is having in his or semester. So what will be the answer? So first we have to specify this. This will be, we have to specify the attribute pi, roll number, comma name, comma branch that belong to the relation student into, that is the Cartesian product, followed by project operation. Which attribute we have to show? Roll number, SPI and backlog, followed by the name of result. Now output will be set of 4 tuples. Output will be set of 4 tuples, student dot roll number, name, branch, result dot roll number, SPI and BL. So here we are getting 4 tuples. As I have already mentioned, the total number of tuples of the resultant relation will be equal to the total, equal to the tuples of one relation multiplied by the tuple of another relation. Total number of tuple in one relation multiplied by the total number of tuple in another relation. This is one more example. Here we are considering only the following tuples: branch equal to civil and semester equal to third, and SPI is greater than 7 and BL is less than 1. So first we have to use the project, we have to specify the conditions. In the first table, only two tuples are meeting this condition, that branch equal to civil and semester equal to third. So 101 Raju civil, semester third, and 103 Om civil branch and semester third, and SPI greater than 7 and backlog is greater than 1. That is, only one student is meeting that condition, that is having the roll number 103. So this will be the query for this. The condition branch equal to civil followed by AND operator and semester equal to third of student relation, Cartesian product, select operation, SPI greater than 7 and BL is equal to is greater than 1, followed by the result. So what will be the result? Result will be only 1. 2 cross 1. These are the 2 rows that we have selected from this table, and this is 1. So 2 cross 1, the final result will be 1. So the resultant expression will be having only 2 tuples. Now next is inner join. See, in database, whenever we have to fetch data from more than one table, then we have to make use of join. So we can make use of join. The join are basically of 2 types, mainly of 2 types, inner join and equijoin. Now first we are going to study natural join or the inner join. It is denoted by the symbol this one. Now it is notated by relation R1 join relation R2 or algebra 1 join algebra 2. This symbol denote the join operation. Now this natural join will retrieve consistent data from multiple relations. If the data is to be fetched from more than one table only, then we will be making use of join operation. In order to apply the join operation, there must be one attribute that is common in 2 tables. If we are using 2 tables, if we are having 3 tables, then these 3 tables should also have some common attributes. So this join operation combined record from different relation that satisfies the given condition. Now the various steps that are performed in natural join. First we have to perform the Cartesian join, then we have to remove the inconsistent tuples, the tuples which are not meeting our conditions. Then we have to remove an attribute from the duplicate attributes, that is the attribute that is mentioned twice. Now we have to perform the natural join between student, so it will be written as student natural join result, right? So what will be the answer? So here we are seeing one of the attribute is common. This attribute roll number is common in both of the table, and in equijoin we have to equate the common values. Only common value is 101 in both of the roll number. So answer will consist of only 101 followed by the name of student, roll number, name of student Raju, followed by branch name, followed by SPI. Now we cannot have 102 and 103 here, because 103 is not present here and 102 is not present here. So only the value that we take in common attribute is the value that matches in both sides. See how actually this operation is performed. First, a cross product is being taken. Cross product is done. This cross product both of these, this cross product both of these. So total we are having 4 rows. Thereafter we will be removing the inconsistent tuple. See, Raju is having no, here the Raju is having 101 roll number, here it is having 103. So again it is causing inconsistency. Here Mitesh is having roll number 102. Here it is showing 101. It is again inconsistent. So this one will also be removed. Again this 102 Mitesh, branch mechanical, roll number 103 and SPI is 9. Again this is inconsistent. So we need to remove all these inconsistent tuples from our resultant equation. So last 3 tuples will be removed from the resultant equation. Now next step is remove the duplicate attribute. See, roll number is mentioned twice. Roll number is mentioned here also, roll number is mentioned here also. So we have to remove this roll number. This is roll number is here also. So we have to remove this roll number, right? So we have to remove this roll number, and our final answer will be roll number followed by name of branch and SPI. So to perform a natural join, there must be one, as I have already stated, there must be one common attribute or column between the relations. One more example of natural join, so that you people can better understand. We have to perform the natural join between branch and faculty. Branch relation is there consisting of branch ID, branch name, followed by the head of department. Faculty table is there consisting of faculty name, faculty ID and branch ID. Now there is a common attribute, branch ID, which is present in both of the table. So only then we can apply the join operation if there is a common attribute in both of the table. Here the common attribute is this one. Here the common attribute is this one. This is the common attribute and this is the common attribute. So one of the attribute is common, so we can apply natural join. Branch, natural join, faculty. Now we will see what will the steps that will be followed. Output will be BID, branch name, HOD, faculty ID followed by faculty name. So this will be the output. So in the output we will be showing both of these things. So net cell we will be having the 2 tuples. So we must see that there must be one common attribute between both of the tables. See, branch BID 1 or 2 is there, 1 and 2 is there. So in the resultant expression BID 1 and 2 is present. Both of the value of branch ID in both of the relations matches each other. So we will include that in our result. Now let us do one more question. Write down the relational algebra for the following relation. A set of relations is given, student relation is there, department relation is there, academic relation is there, guide is there, faculty is there. We have to find the name of the student, we have to find the name of the student, department name and SPI of all the students belonging to civil. So, we have to find out which attribute is present in which relation. Now, department name is present in department table, name of the student is present in this table, student table, and SPI is present in academic, and the condition, the department name is again present here in this one. So, this query will be using three tables, student, department and academic, since these are attributes are present in three different tables. So, we have to make use of join. First, we must understand if the attribute is present in more than one table or the condition is being specified in more than one table, then we have to make use of join. So, the condition is select statement, that is select clause, sigma d name equal to civil, the name relation student join department, department join academics. This is how we will be using join operation. Now, what are the attributes that we have to find? We have to find the student name, then we can find the student name. So, the query will be student name, that is which attribute we are going to make use of, project attribute will be used, pi student name followed by condition d name equal to CE followed by the join operation between three different relations. Now, one more query, display the name of student with project name whose guide is AJ Shah. Now, the name of faculty is present in faculty table, name of faculty is being present in AJ Shah is present in faculty table, and project name is present in guide. So, we will be making use of three tables, student table, guide table and faculty table. So, this join needs three tables, student table, guide table and faculty table, and we will be writing the query as follows, pi student name comma project name, name is also required. So, we can find the project name, we can find the project name. So, pi s name comma project name followed by the condition that the project guide select, for specify the condition we use select operation, faculty name equal to AJ Shah followed by the join between three relation, student join guide join faculty. In this way, we will be able to fetch the answer of this query. Now, outer join is used when we have to show the missing value. In natural join, some of the results are missing. So, for that purpose, we can make use of outer join. For example, there are three types of outer join. Inner outer join denoted by this symbol. This is for inner outer left outer join, right outer join, this one, and next is full outer join. So, let us see how this work. Again, for outer join to work, there must be common attribute between two relations. Left outer join, this is the expression for left outer join, notation relation R1, left outer join relation R2. It display all the tuple of left relation even though there is no matching value in the right relation. For all such kind of tuple having no meaning, the attribute of right relation will be null in the result. Let us see this relation. Suppose we want 102 also in the result, even though there is no corresponding value in result relation. So, for that we have to use left outer join. That is this is the left, student left outer join result. So here we are showing 102, despite that there is no matching value in 103. So SPI, there is no matching value here, so the value of SPI is null. Now the right outer join, for right outer join, we have to display all the tuple of right value of right relation, even though there is no matching value in the left side. So this is, suppose we want to show 103 in our result, despite that there is no matching value in 102, then we have to make use of right outer join. This is 101 Raj Civil SPI is 8, roll number 3, 103. Now this is present here but not present here, so the name is null, branch name is null, and SPI is this one. This is the right outer join. Next is full outer join. Now full outer join is used when we want to show the missing value of both sides. Means it is a combination of left outer join as well as the right outer join. So this one is the symbol for full outer join. It displays all the tuple of both relation, left as well as right. It shows the value which are not matching on left side as well as the value which are not matching right side. Now perform full outer join between student and this one, display roll number, name and SPI. So here we are seeing that we want to show both 102 as well as 103. So we have to make, this value is not present here and this value is not present here. So we will be using full outer join in order to show both of them, and the expression will be like student full outer join result. Now we have to display only certain attribute, roll number followed by the attribute we have to specify by project operation, roll number, comma name, comma SPI. So that will be your final answer. This 102 is from this table. For that we do not have corresponding entry here, so SPI will be null. Now this 103 is in this table but not present in this table, so the corresponding entry for the student is null in this table. Now, thanks. It's all over from my side. You can contact me on my mail ID or contact me on my phone number if you have any query.